Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, and sometimes in between, we discuss the latest bioscience publications. And as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. For today's episode, I'm joined by Dr. Gerald Grant of the University of Louisville School of Dentistry. He's here to talk about 3D printing, and in particular, the use of 3D printing to quickly overcome shortages of necessary medical supplies. In this case, the focus is on a newly designed swab for use in COVID-19 testing, but I'll let him describe it. Dr. Grant, thank you very much for joining me today.
Thank you. It's a pleasure to be here.
Okay, so I was hoping we could start off just talking a little bit about, the role of 3D printing in, medical and dental applications already, and you've done a lot of work on that over the years. So could you just give us sort of a quick introduction?
So the nice thing about the role of 3D printing is that it has its roots in digital scanning and being able to actually image a person for medical side. So the key to that is we've had images in the past, but there's no really way to take that image and to fabricate something that custom fits. We usually had to do that analog with like impressions or something in that matter, which is not exact. With the digital, we can actually design something we want, and then we can go from that digital design and then actually print it or be able to make it right where we're looking at it. The nice thing about printing is it's not limited, much like milling would be. So milling would be if I had a block of material and I cut away things. There are some limitations on the milling on what you can and can't do. You don't really have that issue with the printing. The other thing that's nice about the printing is, bone is not a solid structure, so there are lots of little structures inside. So if you're trying to, when you print, you actually can get those structures in your structure in the part that you're building as well, so you can actually see that. Whereas in milling, it's only the outside surface, and that's all. If you cut something that was milled, it'll be solid, but if you cut something that's printed, it'll show all the internal structures as well. So that has been really helpful in the fact that you can design custom-fitting prosthesis or any types of devices for a patient.
Okay, and what are sort of the most common applications that one would see?
So probably the most common we would see is it's used really quite a bit in doing cranial plates for missing sections of the cranium. Probably see it used more in dentistry than anything else for repositioning of the jaws and surgery to put them back together when they're broken and trauma. You'll also see it a lot in like spine surgery and then for hip replacements.
Okay, and does the element of being able to digitally scan rather than take an impression, does that kind of thing that comes into play, with the a cranium prosthesis?
Correct. So, and originally how you would make one of those is you actually had to do an impression of somebody's head from the outside, and then you were kind of guessing how well it was going to fit, and then you had to customize it in the surgical suite. When you start to scan it, and you're able to, you can just fabricate just the device itself that fits in that area, and it usually, when I've done them in the past, we never had to adjust any; they always go right in.
Okay, that's fascinating and makes quite a lot of sense. Let's talk a little bit and pivot to talking about testing for COVID-19. I think we've all heard quite a lot about many medical supplies that are having supply chain interruptions, et cetera. And I hadn't known that things like surgical swabs were among them. Is that one of the things that people are having a hard time getting enough of?
Right. So as there's a demand for more and more testing, part of the testing is the swabs, and the swabs are made generally, you can imagine the demand for swabs is not one of those highest things on the face of the earth until recently. So only so many are made or manufactured at a time. And if you outrun your manufacturing capabilities, then you have a gap. So what's happening is places are trying to do more and more testing, but they can't because they can't get the parts. Part of it is with some states, such as ours, we were asked to do the swabs because what happens a lot of times is if you're not high on the list, the swabs may go to somewhere else, even though you try and order them. So you wouldn't have access to them, to be honest with you. So you had to get around that somehow. So 3D printing was one of the things they reached and said, can you print swabs? And there were other groups doing it already. So a lot of people have been looking at that. And yes, you can print them, but the answer is it's going to be a stopgap type thing, not something that I would think is going to be, you would order a 3D swab on a regular basis. Because So the 3D printing portions right now that's going on in this whole COVID-19 issue are all gap solutions. So if you can't get enough N95 masks, then you can print a N95 type mask and use a filter that can be used over and over and over again and re-sterilized, which is a little bit easier. So that's a gap answer. It's not really the perfect answer for N95, but it is a gap answer. The other issue was face shields. Now we're pretty much all medical people have to have a face shield, which we've really never done in the past. So you can imagine that wasn't around. So processing face shields became a big thing that goes on, and a lot of people print them. It's kind of a face shields because it's not really a high risk device. It kind of stimulates the printer community. So there's a lot of people that print these things and centralize, send them to the medical. So there's a lot of that kind of activity going on.
Okay, now things like face shields and potential gap solutions to replace N95 masks make a lot of clear sense to me as things that you could easily 3D print. I'm a little bit interested, though, in the way that one might 3D print a swab. At least in my mind, we're talking about something that looks like a very thin wooden dowel with a bit of cotton at the end. It doesn't sound like the best printing candidate. What does the product here look like?
So the answer is on that one is what it does. So generally how they work is they can't use cotton for the reason they have their own reasons of why they can't use cotton. So they use a polyester type of material. So usually a polyester end that's on a plastic handle, small plastic handle. So the key there is you got to be able to print something that has the characteristics that the material can bend, but it won't break, because they're nasopharyngeal, which means they go way up there. So you don't want them to break off, because that could be an issue all by itself, having to go back and get it back out. So you had to develop something that I could literally almost like tie it in a knot, and then it would go back to straight. And then you had to develop a collection device at the end. Normally what seems to work is kind of almost a basket type of structure that you build that's kind of narrow and tubular shaped, but it looks like a mesh inside. So those kind of how you design them.
And I'm wondering now, 3D printing offers an advantage over, standing up new manufacturing for, say, a traditional swab, in that it can be done a lot faster, I would imagine. What was the design process like for these swabs, and how long did it take to put them together?
So the design for the processing was a hit or miss. There are several materials out there, and the key is to find a material that will work on your printer. So number one, we were lucky enough to have a partner in Envision-Tech who had a material that we were able to use. Now we don't have an Envision-Tech printer; we have a NuPro 3D printer, but we were able to make the adjustments on our printer to be able to print the other material. So the only difference is that material, because it's not optimized for that, it's a little slower. So it takes us about 4 hours to print 300 or 400 swabs, because you got to print them standing up. You got to think of it that way. So the taller something is, the longer it takes to build.
Okay, but that still sounds like it's pretty quick.
That's relatively quick. That's still pretty fast. That's not like tomorrow, right?
No, absolutely not. And what's the material like? I hear the word resin, and when I see images of 3D printed things, it looks a lot like plastic to me. But what is the material like? What are its properties?
Well, the material is it's stiff in your hand, but I can take the tip and I can bend a loop in it. So if you think of it that way, I can take the tip, I can bend a loop in it. The other portions that are on the swab is about a little over 6 inches long, and the reason you do that, and then it has a break point. So you want the person using it to be able to use a non-sterile glove to make to get the sample, and then you have to have a break point so it'll break off into the medium tube. So they have a tube of a media that they're going to put it in. So you want it to break off into that, and then they can put the screw at the top on without touching anything above that break-off point. So that's kind of how they're designed to do.
So you've talked a little bit about the speed already, but what's the potential to scale this up? Is there potential to do that kind of thing?
So there is potential. We're looking at other materials as well, and I work well with the other company. The NuPro is actually a relatively fast printer. It can actually print faster than than the 4 hours. Just the material is a little bit different, not designed for that machine. So we've been looking at other materials. We could probably get it to print more than that in probably half the amount of time. So we're looking at seeing how fast that can actually print.
Okay, and what kind of demand are you seeing for these? Is there uptake already? Are these being used in hospital systems?
So my understanding is some hospital systems are using them in other places. There are different types. Right now, there's kind of a community of that. The interesting thing about the swab research is that it's been pretty open. Most of the COVID-19 has been a really open research platform. As a researcher in the past, I'll tell you, I've never seen this much sharing before. There is a general site that was set up that schools have contributed to show that they've tested certain materials and they've done certain things, and whether they've gone through their patient trials and they give you the designs, everything you want to know, basically saying, we did this. If you want to do that, then here's what we did. So there's a lot of guidance on it. So it's not like you had to sit in a basement and figure it out by yourself. There's a lot of guidance out there to kind of steer you away from some materials and bring you towards others.
And just out of curiosity, where does that sharing take place? Is this on GitHub or something like that?
Yes, it's on GitHub. So the sharing is on GitHub. There's a GitHub one for Swab that was started by the microbiologist at Harvard, and it's a very nice. It's very inclusive. It includes several other schools, and ours will probably join once we're finished with our process. We'll put ours into that as well.
Oh, that's a fantastic and interesting element of the story that I'd not been aware of. So a lot of this is being shared pretty openly, and then the manufacture is being done privately in collaboration with private enterprise?
Yes, and somewhat. So for us, we'll do it internally, but certainly if you go to those sites, they'll lead you to another site where there's 3 or 4 manufacturers out there that you just tell them you need this many swabs, and however they manage that, I'm not sure, but they contact you back, and then you decide what you're going to do.
Okay, and are there any other areas, in relation to either COVID-19 testing or otherwise that are being looked at as potential areas where 3D printing could contribute?
Well, I mean, I think those are what they're more geared towards. Is probably the making the parts, ventilation parts. There are certain parts and things that you can print easier than you can fabricate. The limitation between printing and is how many you actually need. So if you're looking in the short term for a lot of parts, printing is probably the way to go. If you're looking in the long term for a lot of parts, then injection molding or some other manufacturing system is probably less expensive and faster. So 3D printing is great for these types of gap type issues where we can put out a lot of material, but the reality is that they're going to be relatively expensive to as an individual device.
And is that expense mainly a function of the materials that are used, or is it the amount that you're taking time away on the printer that could be used doing something else?
Yeah, it's probably a combination. On the manufacturing side is probably a contributor of all of that. So the cost of the material, the cost on and off the machine, and then the post-processing time. So these swabs have to be, they're washed in alcohol for 10 to 15 minutes, and then they're washed again for 10 to 15 minutes. Then some materials are required to have a drying session of about 30 minutes, and then you have to cure them with a light for 10 to 15 minutes. So all those times kind of build into it.
Yeah, and is the post-processing a labor-intensive business, or is it relatively easily done?
Well, depending how you're set up, I guess is the way to do it. If you're a large corporation like Carbon or one of those groups, it's probably pretty well automated and can go pretty quickly. If you're a small company, it might be a little more labor-intensive for you. It just depends on how you set up your builds and how you work your processes from going from one thing to the other. In a university, I mean, it's great because I have, graduate students, so so that's easy. But people build racks; they find ways to do different ways to be able to do that.
Well, that's great, and thank you very much for this overview of this process. I think it's an element of the story that not many of us had a chance to think about in advance of hearing it today. Thank you very much for joining me, Dr. Grant.
Oh, no problem.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.